Hey guys, so today we're going to do a revision video on differentiation. We're going to solve all of the questions that come for differentiation in 2H and solve them also put it in 1H. It's like a mixture of everything because they can give any of these formats. So throughout this video, you will come across all of the different formats of differentiation that can appear in your exam. So let's start with these questions and make sure that differentiation is on point when we're solving paper 2 for H and HR. So first question says that y equals to x cubed minus 2x squared minus 15x plus 5. Find dy by dx. So first we're going to do this simple basic differentiation where we bring the power down, subtract 1 from the power, and then repeat the same steps for each of the terms. And remember that the derivative of a constant will always be 0. So keeping that in mind, dy by dx equals to 3 times x to the power of 3 minus 1 minus 2 times x to the power of 2 minus 1 minus 15 times x to the power of 1 minus 1 plus 0. So that's 3x squared minus 4x minus 15. That is your derivative of the curve y equals to x cubed minus 2x squared minus 15x plus 5. Then it says C is the curve with equation y equals to x cubed minus 2x squared minus 15x plus 5. Work out the range of values of x for which C has a negative gradient. So dy by dx is basically the gradient of a curve or any polynomial. So they're saying that we have to find the range of values for x for which C is a negative gradient. So it's saying we have to work out the range of values of x for which C has a negative gradient, which means dy by dx is less than 0. So whatever equation we got over here, 3x squared minus 4x minus 15, this is less than 0. So now we'll solve this inequality to find the values of x for which C has a negative gradient. So solving a quadratic inequality is pretty much similar to solving a quadratic equation. The only difference is in the way that you're writing your answer. So we factorize this quadratic equation. You can use the quadratic formula or you can use splitting the middle term, whichever way you're most comfortable with. I'm going to use splitting the middle term. So if I do 3 times 15, that's 45. Now we need to find factors of 45. Apart from 3 and 15, it's 9 and 5. Then we have 45 and 1. And we have, I think that's about it. Yeah. We know that 9 minus 5 equals to 4. So we can replace the middle term with negative 9x plus 5x. And everything else comes as it is. So now, once we have replaced the middle term with the factors of 3 and 15, we will split the equation into 2 groups and factor by grouping. So this is one group and this is the other group. So in the first group, we have 3x common. So 3x comes outside and x minus 3 comes inside the bracket. Between the last two terms, we have 5 common. So plus 5 bracket x minus 3. Now, between 3x and 5, we have x minus 3 common. So x minus 3 bracket 3x plus 5 less than 0. Now comes the part where solving the quadratic equation is different from solving a quadratic inequality. What we will do is we will draw our rough axis. One value of x is positive 3 and the other is negative 5 over 3. So since it's a minimum curve for the gradient, we draw this curve. Now they're saying that x minus 3 times 3x plus 5 is less than 0, which means we're looking at the values beneath the x-axis. So our focus is over here and over here. At x equals to negative 5 over 3, we can see that the values of x are increasing. They're going towards the right-hand side. Whereas at x equals to 2, the values are decreasing because they're going towards the left-hand side. Since both the arrows are going to converge at one point, which means x is going to be less than 3, but it's greater than -5/3. This is the way you will write your final answer. If, let's say, your values were diverging will take place when your inequality is greater than 0. So if your derivative was greater than 0, then your values of x would be going in opposite direction. So keeping that in mind, then you have two different inequalities. Then for this case, it would have been x is less than -5/3 and x is greater than 3. So I repeat, when the values are diverging, you have separate inequalities. When the values are converging, you have a joint inequality. And for that, if it's greater than 0, then they're diverging. If it's less than 0, it's converging. But keeping in mind that it's a minimum curve. If it's a maximum curve, then the rule becomes positive. If it's a maximum curve, then the rules become, if it's a maximum curve, then the rule is opposite. Then it's diverging underneath the x-axis and converging above the x-axis. Because your maximum curve basically looks like this. This is your maximum curve, and this is your minimum curve. So this is how you would solve such a question, which is like a very basic question where they're asking you to first differentiate the equation, and then they're clearly stating that you have to find the values of x for which the gradient is negative. So gradient would only be negative if it's less than 0. Then the next type of question says that a particle P is moving along a straight line. The fixed point O lies on this line. At time t seconds where t is greater than equal to 0, the displacement s meters of P from O is given by s equals to t to the power of 3 plus 5t squared minus 8t plus 10. We have to find the displacement of P from O when P is instantaneously at rest. Give your answer in the form of A over B, where A and B are integers. So this is like linked with kinematics, where you need to know that when you differentiate displacement, so ds over dt is equal to velocity. And when you differentiate velocity, it gives us acceleration. You need to remember these things. So they have given us the equation for the displacement, where they're saying that at time greater than equal to 0, the displacement s meters of P from O is given by this equation. We have to find the displacement of P from O when P is instantaneously at rest. If it's instantaneously at rest, that means your velocity is 0, because 0 velocity means that there is no movement of the particle. So for that, we will differentiate the equation first, because we know that differentiating the displacement equation will give us velocity. So that's going to be 3t squared plus 10t minus 8. Now, since it says it's at rest, that means ds over dt will equal to 0. So 0 equals to 3t squared plus 10t minus 8. Similar to what we did in the previous question, we have this quadratic equation now, which is equal to 0 in this case. And we will factorize this quadratic equation to find the value of time, where the displacement of P from O and P is instantaneous. And we will use these values of time to figure out the value of displacement. So let's factorize this. 3 times -8 is -24. So we have to choose factors of 24, which when added or subtracted give us 10. So apart from 6 and 4, we have 24 and 1. Then we have 12 and 2. And that's about it. So we can see that when we do 6 plus 4, that gives us 10. But if we use that, then we'll have just one negative sign in the equation and we won't get the same signs in the bracket when we factor by grouping. But if we use 12 and 2, 12 minus 2 is also 10. So when we take 12 and 2, that gives us 3t squared plus 12t minus 2t minus 8. When we factor by grouping between 3t squared and 12t, we have 3t common. So t plus 4 over here. And between negative 2t and negative 8, we have negative 2 common. So again, t plus 4 here. Now we have the same terms inside the bracket. If we had selected 6 and 4, I'll show you that. So that would have been 3t squared plus 6t plus 4t minus 8. So in the first two terms, we have 3t common. So t plus 2 over here. And the last two terms, we have 4 common. So 4 bracket t minus 2. Since the brackets weren't same in this case, so we couldn't have further factorized it. This would have been the last step over here, which is incorrect because we need to fully factorize the quadratic equation to find the value of t. Hence, choosing 12 and 2 is the better option because we can further factorize this, which would give us t plus 4 bracket 3t minus 2. So where t equals to negative 4 and t equals to 2 over 3. Now, obviously, time cannot be negative because it's a scalar quantity, not a vector quantity. Time has no direction. So we're going to select t equals to 2 over 3 as a time. Now they want to find the displacement at this point. So displacement equation was t cubed plus 5t squared minus 8t plus 10. So in this equation, we'll put our time. So that's 2 over 3 cubed plus 5 times 2 over 3 square minus 8 times 2 over 3 plus 10. That's going to be 8 over 27 plus 5 times 4, that's 20 over 9 minus 16 over 3 plus 10. Let's further simplify this. So lowest common multiple is 27. So 8 plus 20 times 3 is 60. And then 16 times 9, that's going to be 144. And lastly, 10 times 27, 270. That's going to give us 194 over 27. We get 194 over 27, which cannot be further simplified. So this is your final answer. Then the next question says that the point A is the only stationary point on the curve with equation y equals to kx squared plus 16 over x, when k is a constant. Given that the coordinates of A are 2 over 3 and A, find the value of A, show your working clearly. So far we're on the third question, and I think in total I've gathered like 10, 11 questions. So while you're looking at these questions, I want you to focus on the keywords used in these questions. If you see dy by dx, obviously that means you have to differentiate. If you see the word stationary point, that also means you have to differentiate because stationary point is your turning point of the curve. And turning point always has the gradient of 0. If you see displacement and they're asking you to find velocity, or like, they're asking you to find the acceleration when velocity is given, or they're saying that this is the displacement equation and we need to find something when the particle is at rest or whatever. All of these things indicate that we have to use differentiation to solve the question. Another thing, like that's also going to come in the upcoming questions, like when they use the term maximum value. Now, do not confuse maximum value with upper bounds and lower bounds. in upper bound and lower bound, they would indicate very clearly that, something is nearest to this. So you have to find the upper bound for that or like the lower bound for that. In differentiation questions, they use the term maximum value of, let's say they have given us a shape and they're asking us to find the maximum volume of that shape. So that means we will use differentiation. If they're asking us to find the minimum value of like the surface area, let's say, that also means we will use differentiation. So you have to be very careful in identifying the keywords that are used in the question paper, used in the question. And then based on that, you have to use the most appropriate method to solve the question and get the answer. So going back to this one, it says that we have this equation. They have given us the coordinates of A, and A is our stationary point, which means we need to differentiate the curve first. So dy over dx is going to be 2kx plus, now over here it's 16 over x. So I would suggest you writing it down as 16 times x to the power of -1 before differentiating it. Because it's easier to see the equation not in fractions. Because in fractions, you're going to get confused that, oh, do I have to like add one, subtract one, what? So it's best when you have a fraction and the variable is in the denominator, bring that variable in the numerator. And as you know, that one of the rules of indices is that when you want to change the sign of a power, whether you want to make it negative or positive, we just change its place. So if I move x from the denominator to the numerator, the sign of the power changes. So initially it's +1, and when I bring it in the numerator, it becomes -1. So now it's 16 times x to the power of -1 instead of 16 over x. So now when I differentiate this, I bring the -1 down. So it's 16 times -1 and then subtract 1 from the power. So that's 2kx minus 16 times x to the power of -2. For your ease, now you can bring it down and write it as 16 over x squared. I hope that makes sense. If there's still any confusion about this, please leave a comment below and I'll try to help you out. So going back to the question, A is the only stationary point on the curve, which means when you put the derivative equal to 0, we can substitute the value of the coordinates of A in this equation to find the unknown. So stationary point means dy by dx equals to 0, which means 0 equals to 2kx minus 16 over x squared. For A, x is 2 over 3. So if we substitute that in the equation, you would notice that the only unknown left in the equation would be k. And now we can easily find the value of k. So that's going to be 0 equals to 4k over 3 minus 16 divided by 4 over 9. Then to solve 16 divided by 4 over 9, that's basically 16 times 9 over 4. We're taking reciprocal of second fraction and changing division to multiplication. 4 ones are 4. 4 fours are 16. So that's going to be 0 equals to 4k over 3 minus 36. 36 equals to 4k over 3. Cross multiply. 36 times 3 and then divided by 4, which is 27. So we substitute this back into the original equation and calculate our value of A. So original equation is y equals to kx squared plus 16 over x. So y equals to 27x squared plus 16 over x. I have just replaced k with 27 because that's the value. Now, x is 2 or 3, y is a. So a equals to 27 times 2 over 3 squared plus 16 divided by 2 over 3. That's going to give us a value of 2 squared is 4, 3 squared is 9. 27 divided by 9 is 3. So 3 times 4 over here plus 16 divided by 2 over 3 is the same as 16 times 3 over 2, which is 8 times 3, and that is 24. So 3 times 4 is 12. 12 plus 24 is 36. So your value of A is 36. That is your final answer. Then question 24 says that a particle P moves along a straight line that passes through a fixed point O. The displacement x meters of P from O at time t seconds, where t is greater than or equal to 0, is given by x equals to 4t cubed minus 27t plus 8. The direction of motion P reverses when P is at the point A on the line. The acceleration of P at that instant when P is at A is a meter per second square. Find the value of A. So we have like several things happening in this question, unlike the previous question. The previous question was pretty straightforward where they just went from displacement to velocity. That's it. Over here, they're going from displacement to velocity and then to acceleration, which means first, we need to understand what the question is asking. So as the question says, the direction of motion of P reverses when P is at the point A, which means that at that point A, that is our turning point. Because it's only at the turning point where direction of the motion can change. It cannot change midway, in one direction, unless it's a turning point. So if I just draw a rough graph for that, basically, this was your direction of motion first over here. Then at the turning point, this is your point A. It changed direction, now it's going the opposite side. It's not going down, it's going up now. So we have to find the coordinates of A to figure out what the value of acceleration is going to be. So to do that, first I will differentiate the equation of displacement. So dx over dt is going to be 12t squared minus 27. Point A, the direction of the motion of the particle is changing. That means dx by dt is going to be 0 over here. And using this, we will figure out what our time is at this point. So 27 equals to 12t squared. 27 divided by 12 equals to t squared. 27 divided by 12 is 9 over 4. Square root both sides. So 3 over 2 is time. We get plus minus, but obviously time cannot be negative. So we choose positive value of 3 over 2. Now, we know that the time is 3 over 2 at point A. For acceleration, we will differentiate my velocity equation. This is velocity. So dv over dt is going to be 24t. Now at this point, time is 3 over 2. So if we substitute t equals to 3 over 2 over here, that's going to give us the value of acceleration. which is going to be substitute time equals to 3 over 2 in the acceleration equation. This is your acceleration. So that's 24 times 3 over 2. 24 divided by 2 is 12. So 12 times 3 is 36 meter per second square. That is your value of acceleration. So once again, remember, when you differentiate displacement, that gives you velocity. When you differentiate velocity, that gives acceleration. If the question mentions that the direction of the motion is changing, that means you reach a turning point and then the direction changes. If it's just going in a straight line, it cannot change direction without there being a turning point. And if there is a turning point, that means at that point, your differentiation will always equal to 0. Then the next question says that a particle P is moving along a straight line that passes through the fixed point O. The displacement S meters of P from O at time t seconds is given by S equals to t cubed minus 6t squared plus 5t minus 4. Find the value of t for which the acceleration of P is 3 meters per second squared. Similar question to the last one, but as you can see in this case, they're not saying that the motion is reversing for the particle. Over here, they've just given you the displacement equation and they have given you acceleration. All they want you to do is find the time at which that acceleration is taking place. So we'll do 3t squared minus 12t plus 5. This is velocity. Now we find the acceleration. So dv over dt. So that's going to be 6t minus 12. This is acceleration. So we have to find the value of time when acceleration is 3. So 3 equals to 6t minus 12. 3 plus 12 over 6 equals to t. So that means t is going to be 15 divided by 6, which is the same as 2.5 seconds. That's your answer. This question was much simpler and less time consuming compared to the other ones that we've done for displacement and velocity. Quite straightforward. You just have to differentiate your displacement first to get the velocity equation. Then you differentiate your velocity equation to get the acceleration question. And then you differentiate your velocity equation to get the acceleration equation. And then you put your equation equal to 3 meters per second squared. Find the value of the time at which the acceleration is that. Then the next question is saying that the diagram shows a cuboid of volume V centimeter cube. Show that V equals to 15 plus 16x minus x squared minus 2x cubed. Now, this is the type of question that I was talking about at the beginning, where they give you the shape. They ask you to find an equation for the volume or the surface area, and then they will ask you, give us the maximum value of that or minimum value, depending on what the question wants. So first, let's find the equation for the volume. We can see that we have the base, we have the height, we have the length. So volume of a cuboid is length times width times height. So that's going to be 2x plus 5 times 3 minus x times x plus 1. So we're expanding a triple bracket over here. So you can expand the first two brackets first and then multiply the result with the third bracket. So 2x times 3 is 6x. 2x times negative x is negative 2x squared. 5 times 3 is 15. And 5 times negative x is negative 5x. Then bracket x plus 1. Collect the like terms to simplify your first bracket first. So that's negative 2x squared plus x plus 15. Now we multiply the third bracket with the new first bracket. That's going to be negative 2x cubed minus 2x squared plus x squared plus x plus 15x plus 15. Negative 2x cubed minus x squared plus 16x plus 15. This is exactly what was given in the question. 15 positive, 16x positive, negative x squared, and negative 2x cubed. So that's your answer. Then says there's a value of x for which the volume of the cuboid is maximum. So keyword over here, volume of the cuboid is maximum, and we have to find that value of x. So what you will now do is you will differentiate the volume because it says maximum. That means it's reaching this maximum value. And we can only reach a maximum value or minimum value at the turning point of the curve. Not before that or after that, only at the turning point. So for that, we differentiate the equation for the volume that we created in the previous part. Put that equal to 0 because like we've discussed before, at the maximum value, at the minimum value, at the turning point, at the stationary point, all of these things represent the same thing. And at all of these points, the differentiation is equal to 0. So v equals to negative 2x cubed minus x squared plus 16x plus 15. That was our equation. So let's differentiate this now. dv over dx is going to be negative 6x squared, negative 2x plus 16. Like we said, that at the maximum value, dv over dx is going to be 0. So 0 equals to negative 6x squared minus 2x plus 16. Now we're going to factorize this quadratic equation. So before we start factorizing it, I would like to first make x squared positive. So if I make x squared positive, x also becomes positive, but 16 becomes negative. So that's going to be 6x squared plus 2x minus 16. Now you can see that all these three numbers are divisible by 2. So if we divide them by 2, that's going to be 3x squared plus x minus 8. Now I would like to factorize this. Now in the question, they have clearly indicated that give your answer correct to 3 significant figures. Whenever in the question they say that give your answer correct to 3 significant figures, 2 decimal places or 1 decimal place, and you're supposed to solve a quadratic equation, that means that you will use the quadratic formula. There is no point in wasting time on splitting the middle term because that's not going to give you the answer. So directly go to the quadratic formula, put your equation in it, and find the value of x. So a value is going to be the coefficient of x squared, which is 3. B is the coefficient of x, which is 1, and C is the constant, which is negative 8. The sign comes with the number, always. Do not forget the sign, otherwise your answer will be incorrect. So it's going to be negative 1 plus minus root of 1 squared minus 4 times 3 times negative 8 over 2 times 3. That's going to be negative 1 plus minus 1 squared is 1. 4 times 3 times 8. So that's basically 12 times 8, and that's positive 96 over 6. So root of 96 is going to be 9.797 divided by 6. So one value of x is negative 1 plus 9.797 divided by 6, which gives us 1.47. Because we want the answer correct to 3 significant figures, that's that. And then for the other one, it's going to be negative 1 minus 9.797 divided by 6. But since we don't need the negative answer because we have to find the value of x, and x cannot be negative because it's a part of the measurement of the cuboid. So x is 1.47. That is your final answer for this. Then a similar question to the previous one, it says that a solid S is made from hemisphere and a cylinder. The center of the circular face of the hemisphere and the center of the top face of the cylinder are at the same point. The radius of the cylinder and the radius of the hemisphere are both x centimeters. The height of the cylinder is 20 minus 4x centimeters. The volume of S, which is the entire solid, is V centimeter cubed, where V is 1 over 3 xy. Find the maximum value of y. Once again, keyword maximum value, which means differentiation will come, and show clear algebraic working. So we'll begin with finding the volume of the hemisphere. Then we'll find the volume of the cylinder. Then we'll add the two and put the equation equal to the volume of solid S equation, which is 1 over 3 pi y. And then once we've done that, we will create an equation for y just in terms of x, differentiate it to find the maximum value of y. Volume of hemisphere will be 2 over 3 pi x cubed. It's 2 over 3 because it's a hemisphere. And then volume of cylinder is pi r squared x squared times h, which is 20 minus 4x, if I'm not wrong. Yeah, 20 minus 4x. So 1 over 3 pi times y is the same as 2 over 3 pi x cubed plus pi x squared times 20 minus 4x. Let's simplify the right-hand side first. So 2 over 3 pi x cubed plus pi times 20x squared minus 4x cubed. Multiply the entire equation by 3. Get rid of the fraction. So that's going to give us pi times y equals to 2 times pi times x cubed plus 3 pi times 20x squared minus 4x cubed. Now, if you notice, all of the terms in this equation have pi attached to it. So we can get rid of the pi by dividing the entire equation by pi. Divide by pi, divide by pi, and divide by pi. So that's y equals to 2x cubed plus 3 times 20x squared is 60x squared. 3 times negative 4x cubed is negative 12x. Now, differentiate this because it's saying maximum value of y. So first we find the derivative of y. So that's 6x squared plus 120x minus 36x squared. If we notice 6x squared and 36x squared are like terms, so we can combine them. So that's 120x minus 30x squared. Now for the maximum value, we put dy by dx equal to 0. So 0 equals to 120x minus 30x squared. If you notice, 30x is common between 120x and 30x squared, so that leaves us with 4 minus x. So one value of x is 0 and the other value of x is 4. So for the maximum value, obviously y cannot be 0 So we put x equals to 4 to find the maximum value of y. So y equals to 2 times 4 cubed plus 16 times 4 squared minus 12 times 4 cubed. That is going to give us 320. That is your answer. Then the next question says that the curve C has equation y equals to ax cubed plus bx squared minus 12x plus 6, where a and b are constants. The point A with coordinates 2, negative 6 lies on C, and the gradient of the curve at A is 16. Find the y coordinate of the point on the curve whose x coordinate is 3. Show clear algebraic working. So once again, we begin with differentiation because they've also said that at point A, the gradient is 16. So first, let's differentiate the equation. Because they've told us that at point A, the gradient is 16. So dy by dx equals to 3ax squared plus 2bx minus 12. So that means 16 equals to 3a, and replace x with 2 because that's the x coordinate for point A. 2 squared plus 2b times 2 minus 12. 16 equals to 3 times 4, that's 12a plus 4b minus 12. Take the 12 to the other side, it becomes positive. So now what we're left with is 28 equals to 12a plus 4b. That is the first equation. By now, you must know that whenever in a question you have two variables in one equation, that means that we have to create another equation with those exact same variables and solve them simultaneously to find the value. So if you look at the question again, the second statement says that point A with coordinates 2, negative 6 lies on C. C, which is the curve. So if we put 2, negative 6 in the equation of the curve, we will once again have an equation which will just be in terms of A and C, A and B. So that means negative 6 equals to A times 2 cubed plus B times 2 squared minus 12 times 2 plus 6. That's going to be negative 6 equals to 8a plus 4b minus 24 plus 6. Negative 6 minus 6 plus 24 equals to 8a plus 4b. Negative 12 plus 24 is 12 equals to 8a plus 4b. That is your second equation. Now we will solve these two equations simultaneously to find the value of a and b. So if you put them next to each other, we can see that it would be easier to use elimination method to solve these equations. And in elimination method, I would like to eliminate variable b because b has the same coefficients in both the equations. So we're already cutting down one step. So now b has the same signs. That means to eliminate it, we need to subtract the two equations. So we subtract them. 28 minus 12 is 16. 12a minus 8a is 4a, and 4b minus 4b is 0, which means 16 over 4 is going to be a, and a is going to be 4. Now, using this value of a, we're going to find the value of b. So let's substitute a equals to 4 in either of the equations. I'm going to choose the second one. 12 equals to 8a plus 4b. 12 equals to 8 times 4 plus 4b. 12 equals to 32 plus 4b. 12 minus 32 equals to 4b, which is negative 20. Which means b is going to be negative 20 over 4, and that's negative 5. So we're trying to find the y coordinate for the point where x equals to 3. So let's substitute A equals to 4 and B equals to -5 in the equation of the curve, which was y equals to ax cubed plus bx squared minus 12x plus 6. So in this equation, we're going to put the value of a and b, put the value of x as 3 to find the y value. Y equals to 4 times 3 cubed plus -5 times 3 squared minus 12 times 3 plus 6. That is going to give us 33. So when x is 3, y is 33 for that point. That's your answer. Then another displacement question, it says that a particle P moves along a straight line. The fixed point O lies on this line. The displacement of P from O at time t seconds, where t is greater than or equal to 1, is s meters, where s equals to 4t squared plus 125 over t. The velocity of P at time t seconds, where t is greater than or equal to 1, is v meter per second. We have to work out the distance of P from O at the instant when v equals to 0. So to calculate that, first we need an equation for v. And to get an equation for v, we've already discussed that we have to differentiate the displacement equation. So ds by dt is your velocity. So that's going to be 8t. Rewrite this again as 4t squared plus 125 times t to the power of -1. Like I told you before, when it's a fraction, just bring the fraction in the numerator and make the power negative. So now it's going to be -125 t to the power of -2, because -1 minus 1 is -2. So this is your velocity equation. So they're asking us to first use the velocity, find the distance of P. Okay, so first, so they've told us that the velocity of P at time t seconds with t is greater than or equal to 1 is v meter per second. So we will put the velocity, which is ds by dt equal to 0, to find the time at that point. Because using that time value, we're going to find the distance of P from O. So 0 equals to 8t minus 125 over t squared. Let's write this as a positive power now. So I'm going to multiply the entire equation by t squared to get rid of the fraction. So that's going to give us 0 equals to 8t cubed minus 125. 125 equals to 8t cubed. 125 divided by 8. And then we will take the cube root on both sides to find the value of t. So that's going to be 5 over 2, which is 2.5. Now, obviously, when you take the cube root, so 2.5 seconds is your time, which is also greater than or equal to 1. Now we will put this time value into the displacement equation to find the distance of P from O. So the displacement equation was 4t squared plus 125 over t. So we substitute the time value into this equation to find the distance of P from O. So 4 times 2.5 squared plus 125 over 2.5, which gives us a value of 75 meters. So that is your distance of P from O when velocity is 0. Then the next question says that the radius of a right circular cylinder is x centimeters and the height of the cylinder is 800 over pi x minus x centimeters. The volume of the cylinder is V centimeter cube. Find the maximum value of V, giving your answer correct to the nearest whole number. So to find the maximum value of V, once again, we have to make an equation for V. So to find the maximum value of V, which is the volume of the cylinder, we have to first create an equation for the volume. Differentiate that first. Put it equal to 0 to find the value of x at which it gives the maximum value. And then use that x value, put it back into the volume equation to find the maximum value of V. Very similar to what we have done in the previous questions. By now, I think you should be able to recognize the pattern, where it's the same kind of steps happening again and again. And through that, we find the answer. So volume for a cylinder would be pi r squared h, pi times x squared times 800 over pi x minus x. So that's pi x squared times 800 minus pi x squared over pi x. Just rewriting it as a single fraction. So pi x squared divided by pi x is x times 800 minus pi x squared. That's going to be 800x minus pi x cubed. This is our equation for the volume. Now we differentiate this. So dv over dx is going to be 800 minus 3 pi x squared. Since we want to find the value of x at which we're getting the maximum value of volume, we're going to put dv over dx equal to 0. So that's 800 minus 3 pi x squared equal to 0. 3 pi x squared equals to 800. X squared equals to 800 divided by 3 pi. So that's going to give us 84.88. Now we'll take the square root on both sides to find the value of x. And obviously we'll take the positive value because the radius cannot be negative. So square root of 84.88 is going to give us 9.21. That is your radius. Now we will put this back into the volume equation, which is this, to find the maximum value of volume. That's going to be 800 times 9.21 minus pi times 9.21 cube. That's going to give us 4,913.69. We want the answer to the nearest whole number, so that's 4,914 centimeter cube. Then it says the curve C has equation y equals to 4x cubed plus x squared minus 20x. Find dy by dx. Very similar to the first question that we did in this video. So basic differentiation, bring the power down and subtract 1 from the power. So that's 12x squared plus 2x minus 20. Then find the x coordinates of the points on C where the gradient is 4. Once again, very basic. We just replace dy by dx with 4 because that's what the gradient is. And then we solve this quadratic equation. So 4 equals to 12x squared plus 2x minus 20. Bring the 4 to the other side. So 12x squared plus 2x minus 24 equals to 0. Now we factorize this quadratic equation. So you can first simplify this by dividing everything by 2. So that's going to be 6x squared plus x minus 12. Now to solve this quadratic equation, we know that 6 times 12 is 72. 72 is 9 times 8 as well. So we can replace x with 9x minus 8x, and then everything else comes as it is. Factor by grouping. Between 6x squared and 9x, we have 3x common. So 2x plus 3 comes in the bracket. And between 8x and 12, we have negative 4 common. Again, 2x plus 3 comes in the bracket. Between 3x and negative 4, we have 2x plus 3 common. So that leaves us with 3x minus 4 inside the bracket. So one value of x is negative 3 over 2, and the other value of x is 4 over 3. So find the x coordinates of the points on C with the gradient is 4, and these are the x coordinates of the point at which the gradient is 4. Simple as that. And with that, we're done with our differentiation questions. If you guys think need help with any other topic, please let me know in the comments below. And if you think some topic might specifically come in 2H or 2HR papers, please share them in the comments below, and I'll try to make a video for it for the exams. And if you're wondering about the predicted paper that I'm working on, the predicted paper is ready. I have 2 versions. I'll be sharing those versions soon. Hopefully this week you'll have the first version and the second version will come before the exam. So do stay tuned. And I'm looking forward to getting your feedback on the versions as well and letting me know which topics should be included more in the second version and which shouldn't be.